9. We finished with number 8 last time. We're going to start with number 9. I think the ordering on these is mostly pretty good. So I do want to say this. If we were doing number 9 back in like November or something like that, you could totally do number 9 without the method that I suggest here. Can anybody look into the future or maybe the past, or you want to look at it and think, what other method would work really well for this one? Let's say, yeah, it's a L'Hopital's rule question. So if you wanted to do a L'Hopital's rule concept here and try to figure out what's going on, you could. But to be perfectly honest with you, L'Hopital's rule, with all of its conditions and everything, would actually take 3 full cycles to get to an answer. Whereas, if you understand power series, specifically the Maclaurin series from center to 0, you could do this actually a lot faster than if you use L'Hopital's rule. Seriously. So if you need a little hint, look back. Our blue power series are still hanging out there in the back. If you need some help with this, you can. But it does give us the direction to use a power series, center to 0, to try to evaluate this limit. And this really is the faster way.
What was the first way you mentioned you could do it?
L'Hopital's will work, but you're going to need 1, 2, 3 L'Hopital rule cycles, along with the conditions that go with each of those cycles. So from just a time perspective, it's going to be way easier to use power series. Really will.
So would this just be like subtraction and multiplication?
Cancel.
Oh, I guess you can split them up.
So okay. So I think you're listening to what you just said. I think you're thinking about this backwards. I feel like you're trying to take the sine. Ooh, you are thinking about this backwards. You are trying to take the power series for sine and make it look like the thing we're doing the limit of.
Yes.
What I'm proposing is that you use the power series for sine within that to make it a lot easier for you, instead of having to do a L'Hopital's rule. So I'm not asking you to do like the sine of x cubed power series or sine of x cubed minus x power series. I'm not asking you to do any of that stuff. I'm just saying use that to help make that easier than it would have otherwise been. Does that make more sense?
I understand what you want us to do. I'm just confused on how.
Okay.
I think I know what you're saying.
So again, like I totally open with this. Like if I just gave this to you and said evaluate, like the only instructions of evaluate, I would expect that you would use L'Hopital's rule.
I probably would.
I would totally expect you to do it, and that's perfectly fine. But my point with this question is to illustrate how a power series can make this a different process, and I think arguably a much easier process versus 3 cycles of L'Hopital's rule.
Yeah, no,
I
I-
know it well.
Say
It's like
again?
I'm L
Right there.
Well, like, it's just
I just don't know what you're asking.
Yeah.
What you're
I'm asking you to evaluate that limit. Like in the end,
Right,
I want
like, I
you
don't
to.
know how to use that. Like, I don't know how to do it with power. Like that's because this is not asking us to evaluate anything. That's like
Wait.
in the question doesn't say evaluate.
Could it?
Yeah, the question says evaluate that limit.
But not in number 8. So if you're looking at a different question.
Yeah, so number 8, that was my point. Look, like number 8 and number 9 are very different. Number 8 said write a power series for x over 3 plus x, right? This doesn't ask us, now, this is fundamentally so different, using some of the same tools. This doesn't say write a power series for anything. What are we trying to do? Evaluate that limit. How do we evaluate the power series? You just want me to show you? You don't want to.
I just don't understand like where to start. That's what I'm trying to get. Because I don't know what the. Like,
I don't know,
how to use
let me
power series to
ponder
get
this, because I honestly, as of this moment right now, I don't know how to give you a hint without just telling you exactly what to do.
Use your brain.
Um,
All in my brain. Not so good.
So I'm going to go back to what I said at the start. You could absolutely use L'Hopital's rule. You could say, hey, look, the limit of the top and the limit of the bottom are both 0. So let's use L'Hopital's rule. And then you try it again, you say, look, the limit of the top and the bottom are both 0. And then you use L'Hopital. Like, you go through that whole process. Or maybe you could use, I'm just going to say it, because I could, this is like as little of a hint as I can give you. Or you could just like substitute something in for one part of that that will make the whole rest of the process just like done. If I tell you any more, I'm just going to be telling you exactly what to do. The word to substitute.
Oh,
Substitute something in for something that's, okay, here's a little more of a hint, just so you can try to connect the dots yourself. Why don't you substitute something in for that? If you can substitute something for that, then the rest of this will go super easy. Hey, let me point this out. Hey, listen. You're going to think this is a really weird parallel perhaps, but I think it is valid. In Algebra 1, we're talking a lot about exponent rules right now, and a lot of the students want me to just give them the rules, of course, which I have given them the rules over and over and over, and they've written them down, but they're still not making great connections. And so I've tried to transition them over to a place where I want them to just notice something. Does that make sense? I want you to look at this and say, well, I noticed that this was taken to a such and such power. Like, that's right. So if you notice this, then what do you think you should do with it? We go from there. So what I'm trying to get you to do, like I could give you step 1, step 2, step 3. But my goal, and those are going to be really easy for you. My goal here is that you look at this and say, if I'm not allowed to use L'Hopital's rule, what can I do? Oh, well, I noticed that red highlighted thing up there is something that I do know a power series for. And remember that, now listen, this is a really important thing. We've talked about this before, I'll say it again. Remember, for a power series will converge to its mother function, right? Does that make sense? Like the function that it came from, either at the point of the centering point, or over a limited interval of convergence, or for all real numbers, right? Yes? Remember how we found the interval of convergence? So, power series convert to its function, where it came from, either only at the centering point, or for a limited domain, or for all real numbers. So do you see anything up there that converges? Do you think you see anything up there that has a power series that converges for all real numbers? Sine does.
Yeah.
So, this is like, we're kind of talking about discussing why this works. So what I can do, and this is like so fundamentally huge that honestly, like 200-300 years ago, maybe even more like right around 200 years ago, if somebody wrote what I'm about to write, mathematicians would flip their lids because what I'm about to write hadn't even been proven yet. Okay? What I'm about to write is really, it's mind-blowing. Check this out. I'm going to say that this limit, the original limit right there, is equal to this. So I just put plus ... meaning it just keeps on rolling in that pattern, minus x over x cubed. So what they would get all upset about is, why are you allowed to write equals? Because equals is a really fundamentally important symbol. It means the thing on the left and the thing on the right are equal to each other. These two things have the same value. Why is it that I'm allowed to replace the highlighted red portion with this other highlighted red portion, including the ... dots?
Because it goes on for forever.
It goes on forever, and you said?
and it converges for all of them.
Converges for all real numbers. So if I just make those terms just go on forever, right, they just keep adding and subtracting, then the two highlighted things right there, they have the exact same value because the interval of convergence is infinite. Now, if the interval of convergence was only from like -1 to 1, like the geometric series, I would have to put that caveat here and say, well, my method here only works for a very limited domain. But because I've got an infinite interval of convergence here for sine and its power series, I can just say these two things are equal. I don't have to say it's approximately this, or I think it's around this with a certain amount of error. I can say it's exactly what I've put up there. Does that make sense? No? Yes? I'm not done yet. But do you see, at this point, do you see how I have replaced sine of x with its power series?
Yes.
Yeah.
And are you okay with that?
Yes.
So let's do.
So can you go, I know we talked about this a little while ago, but can you explain again why sine converges? Why sine x converges?
That's not a 30-second answer. It's a.
You just have to take it as it is.
No. We proved it in class. You have to do a ratio test with sine's nth term. ratio test with sine's nth term. If I somehow have extra time today, I will, but I don't have time to go back and reprove that right this second. That's like a total rabbit trail off to the right. I want to finish this before I even think about that, okay?
Okay.
So you okay with me substituting those two things? Okay. So what's x minus x?
You're up.
So this x and this x would add right out, right? So they're not there anymore. And you could do a lot of these steps. I'm hoping you could do a lot of these steps, these algebra steps, just all in one shot. So I get negative x cubed over 3 factorial plus x to the 5th over 5 factorial. And I'll throw in another term just for good measure. X to the 7th over 7 factorial plus ... all over x cubed, right? Because the x is added out. Now, what do you see that's going to happen between the denominator and the numerator?
You make cancellations
Yeah, what degree?
of just subtracting 3 from all the exponents.
Yeah, cubes. All the cubes would cancel out. So what this would look like is limit as x goes towards 0. And this is the key to the whole deal right here, isn't it? Negative 1 over 3 factorial plus x squared over 5 factorial. Oh, shoot. I accidentally put a plus where it should have been a minus. There we go. That's fixed now. Minus x to the 4th over 7 factorial. Your oh no is ironic because in a second it wouldn't have even mattered anyway, right? Because now as I apply the limit as x goes towards 0, basically the first term won't be 0, and everything else does go to 0. So this would end up being negative 1/6 plus zeros forever, ... equals negative 1/6. And I'm done. Okay, so there was some algebra involved there, right? You okay with subtracting x's and dividing? Don't let the fact that you're doing a power series get you off of this fundamental idea. The reason why power series are awesome is because they are polynomials. And polynomials are always the easiest version of calculus, are they not? Always the easiest version. If I was going to do this with L'Hopital's, it would take me 3 cycles to get there. Santi, do you really want to see why sine has an infinite? This might be good for everybody. I'm going to do this fast. It's on a video. I don't remember which one, to be honest with you. Sine's nth term. Oh, they didn't write it. Doggone it. So sine's nth term
Justin,
is...
we love
Oh,
Justin.
boy, that was brutal.
You're accepted.
Negative 1 to the n, x to the 2n plus 1 over 2n plus 1 quantity factorial. So that's your nth term. So you just do the ratio test with that. I hope I have enough room. We'll see. So I go limit as n goes towards infinity, and then I do the limit of the ratio of the n plus 1th term divided by the nth term. So I basically plug in an n plus 1 in for all the n. So this would end up being x to the 2n plus 3 over 2n plus 3 factorial times the reciprocal of that nth term, so that would be x to the 2n plus 1. Oops, why am I putting that in the wrong spot? X to the 2n plus 1 and 2n plus 1 factorial. Make sense? And remember, we want this to be less than 1 for this to be a converging, to find the interval of convergence. Okay. So I do a little bit of algebra, and here is what I come up with. Between these two, remember if you're dividing like bases, you just subtract your exponents. Won't that just end up being x squared in the numerator when you do the subtraction?
Mm-hmm.
So this would be x squared times, so with the factorials, I'm not going to be multiplying by anything. With the factorials, you know that 2n plus 3 factorial would just be 2n plus 3 times 2n plus 2 times 2n plus 1 factorial, right? So what I can then do is I can cancel out, and I am skipping some little detail steps here. I hope that's okay. Wouldn't that be the only stuff that's left over after I do this? Oops, getting one step ahead of myself. So here's the thing. X is going to be some real number. I don't know what it is, and frankly, I don't really care what it is. I just know that it's going to be real. And here's the thing. The denominator, and goodness gracious, Mr. Anderson, what are you doing? This is an n. I'm going fast, you can tell. So here's the thing. As n goes towards infinity, doesn't the denominator get gigantic? And if the numerator is some constant, even constant squared, some real number squared. If I divide that by something that's getting infinitely huge, what will I get?
Zero.
So this means I'm going to get, I'll just pick this up and move it over because I know that 0 is less than 1, right? So 0, like there's no x in there, right? So what this is telling me is because when I do the ratio test, the limit of my ratio is always 0 with no variable, like it's just 0, and 0 is always less than 1. Here's what that means. It doesn't matter what I plug in for x. It doesn't matter. I'll always get 0 is less than 1. And so since it doesn't matter what I plug in for x, could I plug in like a trillion? Yep. Could I plug in negative 50 bazillion, kajillion, whatever number you can think of? Yep. You can just keep adding numbers onto the end, and then just numbers could get bigger and bigger or smaller and smaller. And because it doesn't really matter what x is, I'll always get convergence. We can say from negative infinity to infinity. Does that make sense? Okay, cool. All right. So if you did L'Hopital's rule here, in my personal opinion, it would take you way too long, way longer than it should have. And so that's why I think in this case, maybe a power series would be a great way to go. So again, we're shifting gears a little bit. So like the previous 2 days, we've done a lot of work with how do you write a power series using those as your foundation, right? And obviously you just saw we shifted gears a little bit. We used one of those to help us do something else. Number 10 is a whole other gear shift. Look at what number 10 says. This is what I meant earlier when I said you got to be like intimately aware and familiar with those right there. He did have 2 nth terms, he just didn't have the first 2. It's okay. So this one, number 10, listen now, number 10 is asking you to do something a little bit different. It says, here is a power series. It's 1 minus x squared plus x to the 4th over 2 factorial, so on and so forth. And they want you to recognize what function could have made that. And if you don't know those, you see why you don't have a prayer?
Screwed.
You have no prayer. No chance. If you could develop those, you maybe would have a chance, but now you're like 5-10 minutes into it, and it should have been done, honestly, should have been done in like 30-40 seconds. Question or thought?
Yeah, as it pertains to this question.
Yeah.
Kind of
Yeah.
Can you, so if you've got a variable expression inside of a factorial.
A variable expression,
So
like the n.
Like, I'll just write it out, it's gonna be a lot easier.
So while he's doing whatever he's doing, will you guys start thinking about this? I suggest you use those power series in the back and be thinking, which one does this look the most like? And then think about specifically which function this would come from.
So, a variable expression with a constant in it inside of a factorial.
Sure.
Can I factor out the constant?
Oh, okay. So it's not really related to this.
Oh, it's not?
Not to number 10? I don't think so.
Because I feel like I could.
Because then you would just, it's the cosine one, then you take out the 2. And
Yeah, you
then
take out the 2 because it's 2n factorial.
Take out the 2.
Yeah, because in the denominator of the cosine summation, it's 2n factorial,
You take out 2.
and you could just take out the 2, and it would be the.
I don't think this is cosine at all.
What?
What?
Oh no.
Mr. Anderson.
How?
It's
Oh,
alternating,
it's how
it's
it's
the
even.
It's
even.
alternating and even.
Is it even?
On the
is it
X
even
modes.
the X then? No, wait.
And then if you divide the denominator by 2, that's you get that every time.
Wait, oh, you could just multiply e to the x by negative, or like.
You
no,
guys are
not
starting. You
negative.
guys are proposing some really good ideas.
You have to make e to the
You
x.
just
The-
make e to the x alternate.
The key to doing like this recognizing thing is the factorials. The factorials are going to be the much harder thing to manipulate.
Okay, so you can't factor out anything out of a factorial?
Wait,
So there is a way, believe it or not, there is a way to do fractional factorials, but that's what you're proposing isn't really it. I would like, I'll put it like this. Like, I totally see what you were going for there, but, and then this is where, like, I'm not even sure what to do with what you just, like the 3/4, because think about it, when
I wasn't
n,
using that was just an example.
okay, but even using that example, if n is 1, the output would be 3/4 factorial. You know what that means? It relates to something called the gamma function, which is in and of itself an accumulation. Okay, you ever thought about how, we all can do like 5 factorial, 10 factorial. You can't do negative factorial, right? But have you ever thought about 7/8 factorial? 21/5 factorial. It's actually been proven that that can be done. It uses this thing called the gamma function, which is an accumulation function, really fancy, way out, way beyond where we are in this class function. It's not where we're going to go. So we might be able to do something with that, but we won't be doing that. Yeah. I would not choose, listen now, my first course of action with something like this would not be, how can I fiddle with the factorial?
Okay.
I wouldn't do that. My first course of action would be, what is the factorial pointing towards? The factorial should give you the bigger hint. So when you look at the factorials there, which one does this seem to point at? Yeah, because e to the x is the only one where factorials go 0, 1, 2, 3, right? Huh. Okay, so then what on earth could make this? How could I turn, and this is where what we did before will inform what you do now. How could I turn that e to the x power series into that? What would I need to do? Turn it into an alternating series, you're right.
Negative x to the n.
So close. What would I do? What would I do with that thing? You just said it. What would I do with it? The negative x to the n.
You would multiply it by 2.
Negative x squared.
Oh, yeah, you would.
I think the n should be a 2. Okay,
Sure.
and what should I do with the negative x squared?
Multiply.
Not multiply it.
Or substitute.
It's substitution. There we go. So here's what I'd want you to do. I'm going to try to write your thoughts down, or what I hope your thoughts would be. You look at the factorials, and you'd say, well, the factorials seem to be pointing me towards e to the x. Because I'm really good and I know the power series for e to the x. It's a non-issue for me, right? And I'm speaking like you are, because you know the power series for e to the x so well. You're like, oh yeah, factorials, it's telling me it's probably an e to the x. Okay, so the factorials for e to the x, of course, we've got 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus ... So now Meg and Aiden and Peyton's ideas of like, what do we do with this negative x in there, negative x squared, what do we do with it? If we try to substitute it, we try it out and we say, all right, e to the negative x squared. If I just replace all the x's with negative x squared, well, the 1's still a 1. The x would be minus x squared. The next term would be negative x squared squared over 2 factorial. The next one would be negative x cubed, or negative x squared cubed over 3 factorial plus ... And this might be where you need to do a little bit of simplifying. Don't be afraid. I think you should be bold and say, I know how to simplify this stuff. So e to the negative x squared would be 1 minus x squared. Excuse me, a negative x squared squared is a positive, so it would be x to the 4th over 2 factorial. This would be minus x to the 6th over 3 factorial. And then we compare. And we say, does that look the same? Yeah, it does look the same. Therefore, well, so I don't want to boil it down to just a singular idea. I was trying to write down your thoughts. Step 1, if it says identify the function, listen. The first thing you look at is the factorials. I'm trying to give you hints. Now, if you don't know those, you don't have a prayer,
Yeah.
right? So if you look at the factorials, what if the factorials went 1, 3, 5, 7, 9? What does that point you towards?
Sine.
Sine. What if the factorials are 2, 4, 6, 8, 10? Cosine. What if the factorials are 1, 2, 3? So do you see what I'm saying? Like it can be daunting and think, oh my gosh, how am I going to identify this? But it's really, is it 1, 2, 3, or is it evens, or is it odds?
Yeah.
And if you can notice that, well, now you're pointed at sine or cosine or e to the x, whichever is appropriate. And you say, all right, in this case, the factorials, they pointed me towards e to the x. Now, all the work we did in the previous 2 days of like multiplying by this or substituting this in and that kind of thing, that's what needs to inform what comes next. So my next thought is, how do I take e and turn it into an alternating series? I know how to make e a negative series, just multiply it through by some negative thing. But how do I make e an alternating series? Well, because the exponents go 0, 1, 2, 3, 4, 5, if I just plugged a negative in there, don't negatives start to alternate when they get to the 0, to the 1st, to the 2, to the 3, to the 4, to the 5, right? They start to alternate like that, and I'm like, okay, I can make it alternate, but then how do I make the exponents go 0, 2, 4, 6, 8, 10? Well, the only way to get an even number is to take 2 times any other number, as long as it's an integer, right? And I'll start to get evens. And so you need to try to put it together. Noticing, like, if all you did was look at this and expect yourself to just be like, oh, e to the negative x squared. I don't know. Probably not going to happen, right? But if you start to notice all the little details, like, oh, factorials. Oh, and now it's alternating. How do I make e into an alternating? Okay, well then how do I make all the exponents even? You're going to need some practice with this, right?
Yeah.
And this is one way of doing it. You'll find all this in your 9-9 to 9-10 homework. We'll have some good practice here. It really will. Okay, so in the end, your answer would simply be the blue box. And frankly, if you did all your practicing and you did all your studying and work, and you got to a place where you could just stare at that and just make the direct leap from there to there, I would actually be okay with that. I don't really need to see all your in-between steps. I mean, if you want to write them to help you, well then by all means, do it. Don't hesitate. But if you could just get to a place where like, okay, this and this and this and this, and okay, and this goes here. Ah, it's e to the negative x squared, then you just maybe check it real quick. I'm okay with that. Totally okay with that.
Do you throw at the nth term?
Nope. It didn't ask for the nth term. It said, now, this is really important. The question says, what known series could you use to determine the function? So the answer isn't an nth term, it's not the series, because the series is right there. It wants to know which function could it produce this. So let's think about this backwards. Couldn't I take e to the negative x squared and say centering point is 0 and do a polynomial? I could say, all right, f of 0. F of 0 is 1, right? And then f prime of 0 times x. Well, end up being a 0, right? And I could do f double prime of 0 times x squared over 2 factorial. And I could go back and rebuild this power series, like from scratch if I wanted to. I don't recommend that unless you just want to check it. That's fine. In the end, the answer is just a function that produced this. And the way to do it fast is to know your power series, those 4. That's the way to do it fast. Okay, let's try number 11. So number 11 is similar to number 10. Same instructions exactly, different series. Use a known series to determine the function represented by, please don't just shout it out if you think you know it. Let's let everyone kind of process for a couple of minutes and just see if they can figure it out. But you do need to start with the information on the backboard. And if you look at that and you think to yourself, I don't have any idea what those power series are, you need to put in some time writing them down, looking at a paper. Like, I don't know, I think for most of you, writing them down, like if you wrote them down 2 times a day for the next like 3 or 4 days, you'd have them. You really would. If you don't do any of that stuff, you might not have them. And that would be bad news.
Some good news. I know what graph I want to manipulate, or what function. Bad news is
I don't know.
So here's some other ways to think about it. Here's some other like things to like kind of filter. Once you think you know and let's not say what it is, once you think you know the power series, ask yourself the question, what did somebody do to this? Because you know that somebody either substituted into it, or multiplied, or divided, or integrated, or differentiated. You know somebody did some like familiar process to it? And look for a pattern. This is a really key mathematical skill, like looking and discerning patterns. It's a good opportunity to do that. So ask yourself, once you have it settled as to which function makes the most sense, which power series makes most sense, ask yourself, what did they, whoever they are, what did they use with it?
That's how you do it.
Oh my gosh, yeah, that is right. I was trying.
Okay, did you figure it out?
I think so. Maybe.
Good.
Crushed it.
Oh, wait. Oh,
Let's go. I got it.
But again, Meg, let me point out, like if you don't have that either up here or right there, you don't get it. So make sure you've got that in your head.
Memorize that. Forever. Not just the test. You're mad.
I don't know about forever. I'm hoping when you're like 94 and
No,
that's
it's
that, you know,
definitely
like,
right.
Okay, here we go. What's the first thing you look at? What's the big hint about which function we're looking for?
Why would you do that?
Hey,
That's right. There's a
what is your big hint?
The factorial.
The factorials should point you in the right general direction. Okay? So factorials are, at least the ones I can see, are 3, 5, 7. They're all odd. So what does that point you towards? Sine. Okay, so then maybe I think about this. Maybe I write this down. I think to myself, well, I know what the power series for sine is. It's one of those alternating power series, and basically everything is odd, which is, of course, what pushed you towards it in the first place because of those odd factorials. Okay? So honestly, like when you look at this, doesn't this, I mean, sine, like right away, this almost looks exactly like what we have, except all the degrees are like down by 1, right? So instead of x to the first, it's x to the 0. Instead of x cubed, it's x squared. Instead of x to the 5th, it's x to the 4th. If you try to match this term with this term, every single degree is down by 1. Factorials haven't been changed at all. As I compare these, I'm just noticing, well, gosh, all of the x degrees are just down by 1. So how do you make a degree go down by 1? Division, yes. What would I specifically divide by? So if I just divide sine of x by x, I would get that exact power series and I'm done.
Oh, that's what you were trying.
I'm looking for the function that would generate that power series, what I was asked about. And if I just divided everything through by x, and of course if you divide, maybe I should say this, check this out. I think sometimes it's super easy to lose sight of the fact of what we have going on here. We're saying this, of course. And of course, you guys noticed, like Meg said it right away, Peyton said it pretty quick too. If I just divide the right side, hey, listen, Logan made this comment the other day. He said, I'm like kind of weirded out by the idea that we just need to balance out each side of the equation, right? I mean, that's really all we're doing. So you said, hey, if I divide the power series by x, then I get the power series that I'm trying to match. Well, whatever I divide the right side by, what do I have to divide the left side by? The same thing. Okay? And so then you can see that this really does equal this, which equals that. So my answer is that right there. Because it asked me which function would generate this power series. Well, sine of x over x. Which ironically isn't defined as 0. There's a hole there. We still generate a power series for it by moving the centering point where we want. Anyways, that's a whole other issue. Okay, why don't you guys take a look at number 12. Number 12. This is going back to writing a power series now, right? This is going back to what we did the first 2 days. Hey guys, we're going to do number 13 as well. Please be efficient with your time. Try number 12. Question 8.
So, can you have like two general terms that equal the same thing, but if still the general term of the series, right?
Well, hold on. 2 general
Because
terms.
they're effectively equal.
They are effectively equal. I'm a little bit lost.
Or well, they're like 2 forms of the general term, I guess. At least what I.
So you have 2x to the 2n, or, oh.
So, is that so we can have like.
Why? So these are all positives,
Yeah.
correct?
Yeah.
Why would you be concerned about this?
Because I was just checking my work to see because I actually did the addition of the 2 terms. I mean, it still actually works out because every other term.
Oh, you're talking, I see what you're saying. You took I get what you're saying. You took like those original nth terms and then tried to add them up.
Yeah.
I mean, interesting.
I know they're equal.
I gotta think about how that would work, right? So, I'll think like that. That's interesting. Can you guys name what known power series we would kind of start off with on this one? Yeah, geometric. Yeah, clearly it's a couple of geometric things going on. And one of them is just the basic geometric power series, right?
Easy. Do you have to use a power series, or could you use the derivatives and then do it again?
Use the
Like,
derivative.
just do like the, like the.
Oh, totally. Yeah, you could do. You mean like a Taylor construct?
Yeah,
Yeah, you really could. That's going to take a while.
yeah, it is.
Yeah, it's going to take a long time because I suppose you could maybe add the two together, get a common denominator and add. That might make it a little bit easier, but otherwise you're going to have like two sets of derivatives going the whole time. They're going to look sort of alike but different, and it's going to be a mess, right? It's going to be a lot to keep track of. Here's what I'm thinking, Santi. I would say this.
I was just doing it.
Oh, and then they have to,
Yeah.
1 minus x plus 1 plus x. 2.
So Santi, in my mind, this is this, right? I've just substituted negative x in for x.
Oh, okay.
And then the other one is just the unmodified. Geometric. So I would say that this is this. And we're going to find, so I wrote the first four terms. I think we're going to find out pretty quick that what I've written up there so far isn't quite enough, is it? Because when I go back to writing f of x, I get 1 plus 1 is 2. But then wouldn't my first degrees add out?
Squared.
So you get plus 2x squared.
Plus
Plus 2x to the 4th.
And so then, yeah, I'd have to continue on, right? So I'd have to think, okay, this is really plus x to the 4th, minus x to the 5th, plus x to the 6th. And then over here, I'd have to continue on as well. 4th, 5th, 6th. So then the third degrees would add out. The fourth degrees would not. I'd get two of those, so it'd be plus 2x to the 4th. The fifth degrees would add out. And then the sixth degrees would add up to be 2x to the 6th. And then my nth term, I think, would just be 2. That 2's kind of unavoidable, right? And then I would say x to the 2n makes the most sense because all of those exponents are even. You know, I'll keep doing some thinking about what yours. I'm sure we can reconcile it.
Yeah, I know that it does work because this then just alternates between 0 and 2, so that means on every odd
Of course,
number,
every, yeah,
0,
that
and
makes
then-
sense, right?
yeah.
Okay, yeah. Because, yeah, you were missing all the odd degrees. Okay,
Yeah, I still did the
I can buy that.
limits, or the
So writing it like that, like with the word or, you said, okay, this or this. Huh, interesting, I like it. Okay, what do you guys think?
Would you have to do the plus dot 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 for this, for the blue part too, on the initial equation?
Yeah, I probably should. I'm glad I didn't because I just needed to add to it. But yeah, that's totally fine. What's the centering point on this new f of x power series? Centered where? No.
it's still 0.
Centered at 0, right? If it was centered at 2, all of these x's would be x minus 2's,
Oh.
so on and so forth. If it were centered at 2.
It was a trick question.
Yeah, the 2 obviously is a multiplier. It's going to make the numbers get bigger faster, but centered at 0. And what would you guess the radius would be? Radius is 1. If you wanted to check the endpoints, I think you'd get divergence at both endpoints. I think you get just negative 1 to 1 open on both. Okay, so I really wanted to get to number 13. We're going to get there. This will be a good place for us to finish. This will leave you guys with 2 of these to work through tomorrow, which theoretically, hey, listen up. Theoretically, this should allow you to then also have some time to work on and discuss homework during class, perhaps. I think I'll include a video of me working through 14 and 15 for the sub to play for you once you have it. So So there you go. So number 13 is a little bit of another gear shift. And to me, the big shift is with the first two words. So that tells me that if you don't use integration somewhere in here,
You're gonna be
you
lost.
either messed up or you created a big mess for yourself or it took way longer. And Aiden is starting to see it. You need to be able to see something. Please don't blurt it out. Try it if you think you've got it. But it does give you the big hint of you're going to want to use integration. Right? The first four terms in the general term power series for f of x equals ln of 1 plus x. And if we have time, we'll talk about an interval of convergence.
That's crazy.
You see it?
Oh, yeah, I'm
It's awesome. So I'll go back to it. If you wanted to,
Oh, that's
you could totally do like the Taylor construct and say, all right, let's do f of 0 and f prime of 0 and f double prime of 0. And things would get like pretty, by the time you got out to that fourth term, things would get pretty big as far as the derivatives go. But we can just use one of those guys and just a little manipulation to get there pretty quick. Because it's a polynomial. And polynomials are awesome. They're easy. ln of 1 plus x, not as easy. There will be another one of these for you tomorrow in the regular notes, and there's several others within the homework as well. So. Meg, I'm going to give you there's potential for an awesome light bulb moment here. The key words here are using integration, and of course the known power series to try to do this.
Okay.
Using integration. See if you can see a little bit into the future. Should be in good shape. You know what? I don't think I can remind you this enough. It's the why would anyone study this? Comes down to this. Polynomials, always easier than other stuff. When it comes to programming, calculating, evaluating, approximating, integrating, all that stuff. Polynomials, easier. Other stuff, harder. It really is just that simple. Meg, I've got some extras of these.
No, I have a notepad. I just like to.
Okay.
I only like.
This is not very word problem intensive, so it's fine. It doesn't make much difference, probably.
I don't know why.
No problem.
Thank you. Yep.
Okay, well, we're a little bit up against our time. Anybody want to offer a first just thought? Like, what was the first thing that kind of hit you? Maybe we should do this. Logan, what do you see?
Well, I know that the interval of convergence is the same for the derivative of each function. So you just do the derivative of f prime of f of x, you're going to get 1 over 1 plus.
Okay, this I would approach this like from 180 degrees opposite. We're going to meet in the same place, though.
Mm-hmm.
So Logan says this. Let's do f prime of x. And when you did that, what did you get?
You get 1 over 1 plus x, which you can turn into a polynomial.
Okay, so let's stop right there. So you noticed this because you're starting to get to know those really well, and you probably thought, ooh, 1 over, if I did a derivative, I get this 1 over 1 plus x thing, and I know that I can make that fit with that, right? So this is where that extreme familiarity will really aid you. Yeah, okay. So what would be the power series for 1 over 1 plus x? First of all, it's geometric, right? And what would I do to manipulate that to look like that?
You substitute in negative x.
There it is. Okay. Do you see how numbers 12 and 13 I put them back to back for a reason?
Mm-hmm.
Okay. So it would be 1 minus x plus x squared minus x cubed plus ... plus it would be negative 1 to the n times x to the n, right?
Mm-hmm.
Okay. For a general term. Okay, so we've got this lovely power series now. What do I need to do to it to get to the thing that I'm looking for?
You need to integrate it.
Yes, it says using integration. Yes. So if I integrate both sides, or technically the way that I've written it here, it would be like all three sides, I guess, because I just connected these all with a nice couple of equal signs. If I do all this, I can now go back and say, well, f of x equals natural log of 1 plus x. Hardly a surprise there. We already knew all that. But then if I just do my antiderivative of my polynomial terms, I'll be there. So it'd be x minus 1/2 x squared plus 1/3 x cubed minus 1/4 x to the 4th plus ... It's still alternating, and it would just be x to the n plus 1 over n plus 1. And I'm done. What do you think? Kind of cool? Yes, I hope. I think it's kind of cool. Anyways, so your final answer here really ultimately would be this, because they asked you to produce a power series with an nth term. And that is different from like numbers 10 and 11. They didn't actually ask you to produce a power series. They asked you to use a power series. Number 9 was kind of like that too, I think. But that would be. Okay, so you guys ready to tackle the final day? Tomorrow it is. Don't forget your quiz. Reviewing what? When?
The unit before we do.
Let's talk about that real quick. So tomorrow is your last day. Tomorrow would be a great review day too. Basically, the last day or so has sort of been a review. We've just been practicing, right? Practicing. Tomorrow's no different. On Monday, we have our 9-7 and 9-10 quiz. Wednesday, if you looked at the calendar, is just review. I'm going to hand back the quizzes and we just talk, right? And then your last test is split up between 2 days. And I did it that way to have you not have to stay after school. It could either be one day and stay after school, or 2 medium-sized days, right?
I'm fine with that.
So that's kind of the plan.
So it's Thursday and Friday?
Yeah, Thursday and Friday.
Will that be split
I'll
up by
do
content?
Thank you.
Like,